Hey, hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome to this video demo of industrial machine overheat monitor developed using Cortex microcontroller and TDCI. So this project monitors machine temperature in real time, providing alerts and triggering actions when overheating is detected. We will explore how the system works, the components involved, and how TDCI enhances the communication and efficiency. Okay, come let's see what is TDCI first. TDCI, Target Device Communication Interface. So the host is sending a command to the target monitor, either a Cortex or Arduino anything. So here we are using a Cortex board. So the host is sending the command to the target board via the serial communication, and then that command is processed by the target board and then send the response back to the host via the serial communication. So this mechanism is using in this TDCA. So now let's see the overview of the project. The Cortex microcontroller actually continuously monitoring the temperature data from the sensor, and then the temperature sensor measure the machine's temperatures accurately, and then either a buzzer or LED activates when the temperature exceeds a safety threshold. And then the TDCA enables real-time data communication between the hardware and the host system, allowing a remote monitoring and control. So the primary goal of the system is to prevent machine damage by providing a real-time overheat detection and alerts. So now let's see the components. Temperature sensor. So here we are using a LM35 sensor for measuring the temperature. So this temperature sensor provides an analog output proportional to the temperature in Celsius. And then you can go for the next component is our target board, Cortex microcontroller, so which act as a system brain processing the temperature data and controlling the output devices. And buzzer, which provides audible alerts when overheating is detected. And then the TDCA mechanism that facilitates a seamless communication between the cortex and host system for real-time monitoring and dynamic adjustments. So the host system actually sends the command and monitor the temperature readings in real time. This Cortex microcontroller continuously read the temperature data and check for overheating conditions. If the temperature crosses the safety threshold, then the microcontroller triggers an alert. And then the TDCA transmits a real-time temperature data and alert status to the host system and allowing for an immediate action. The LM35 sensor measures the machine temperature and sends analog data to the Cortex microcontroller. Then this Cortex microcontroller converts the analog input to a temperature value and compare it against the predefined safe limit that we already set as a preset as a threshold value. If the temperature exceeds the threshold, then the microcontroller activates a indication to signal overheating is happening like that. So the TDCA transmits the temperature data and alert status to the host system where it can be logged, displayed or used for further action. This continuous monitoring ensures a quick detection and response to prevent the equipment damage. So we can use this project widely in for protecting machinery from overheating by providing early warnings and preventing downtime. And also we can implement in power plants like monitoring a critical components to ensure operational safety and compliance with the temperature limits. And also we can use this project for detect and prevent overheating in industrial areas and air conditioning systems, etc. And then we can ensure the safe working temperature to avoid malfunction and damage to the sensitive electronics. So these are the wide range of areas we can implement this project. So now let's see the coding part. Okay, coming to this coding part, you should include TDCI.h header. So this is the main header we should have to use the TDCI API calls. And coming forward that from OS applications dot function call. So this is like a main call. You should initialize TDCI init with your comport. So this is the API to make connection between the host and target port. So don't forget to use this API and then the following STM code. So here I'm using ADC API call. So now I'm going to run this console by right click open with system editor. So here you go with the console output and it is executing the APIs one by one, and then you can see everything is getting either success or failure or whatever the status you get. And then you can also see the temperature value. So this is the normal param value data is giving you, and this is a calculated temperature value. You can also see that the status, param, type, size and value, everything, and then the calculated temperature. If it is temperature is high, then buzzer should be on. If temperature should be normal, then it goes to buzzer off state. So let's see the hardware setup now. Coming to the hardware setup, so this is my Cortex board, an LM35 sensor, and then buzzer for alarm. So I gave the required connection between the target and the components. So now I'm going to run this project. Make sure you should reset before start of this project. Now I started running this project and it started executing the APIs one by one, and then it is detecting the environmental temperature and then giving you the temperature value. So when this temperature exceeds the threshold value that I set, so that time the buzzer will do alarm. It may be do buzzer will alarm or not, because the temperature sensor is detecting the normal temperature of our environment. So if it got increases the temperature, then that case the buzzer will alarm. So now it just giving you the temperature value results, and then you can continuously monitor the temperature of the your surrounding. Either you can use this on your industrial equipments, you can detect the temperature of that particular equipment or industrial areas and etc. So now according to my place, it just detect giving you the temperature range, so that my buzzer is not alarming as of now. If in case I'm producing more heat, I'm putting on more heat on this, so maybe that case buzzer will give you alarm. You can also see that in the console output I showed you before, so that this is how we can monitor the temperature for multiple purpose. So in conclusion, the industrial machine overheat monitor demonstrates how the Cortex and TDCI work together to provide reliable real-time temperature monitoring and protection. So from factory equipment to power plants, the system enhances safety, reduces the downtime, and produce supports to the dynamic adjustments. So thank you for watching. If you found this video helpful, don't forget to follow us. Please drop your questions or thoughts in the comments below. So stay tuned for more innovative projects.